A little sidebar note. I found this little guy right here. At first, I was kind of a little hesitant about it, but I actually really liked it. It did really good. I've been studying Z function tonight pretty hard on the tablet, and I was also doing a lot of computer engineer, C++ stuff, Python. I mean, I can only get so far through it because, even this stuff I do better with. I handle it, I retain it a little bit better. But, without Catalyst, I'm just dead in the water. This stuff was fun. This helped me a lot try to understand, like, some of the base rules. I actually was another one that kind of like in 5 minutes shotgunned it. And, kind of combinations of those intros on all these were pretty useful. But I want to actually start it here.
This is 1 divided by e to the infinity.
Okay.
We're given this wave function.
So he's about to break that down. And real quickly, you need to start with a visual object. I need to be able to make that on the computer. That'll be hydrogen on the very low end first order of the mathematics when we do Dirac's equation and stuff like that. He doesn't realize that's what he's doing. I don't know. I mean, like, I know that this is going to go high and low charge for Fourier and Laplacian. It's immediate. You watch him do it. He's going to tell you this equation describes this graph, and this is essentially a mass shell. There's no reason why you couldn't say isn't that. Might be a little open-ended here, but the first order, second order, and third order approximation 1.0046 hydrogen into helium 4 point whatever s orders s1 s1 1s1 so on and so forth 2s2 I think it's sp p order sfd at any rate first order all this ones and zeros the computer doesn't even know. You have to get letters and numbers going before it'll even understand what this is, but technically it's because it's zero. But zero is stuff in the way that it's like 1 0 1 1 0. It's stuff. It's integrated into this because he's about to break all that down, and it's in some folding matrix. My point, calculus programming.
Right here, and we're asked to figure out what the amplitude is and then the probability of finding it between this point negative a.
Okay, he's gonna get going here.
Well, in order to find a, we're gonna have to.
We need to set this up in terms of we need a computer program, a hello world, a ball, something, this geometry. I need you to make this on a piece of paper. I need to center it in the paper. I need to do all those things. And the kids in a 1-day class, 5 hour, it's got to be 1 day, 1 hour, whatever it is what's X. That is the wave function, students every day. The A here is more like a derivative. Gravity, E, this is the largest form of it, I'd imagine, or the smallest number. Very high, very low, Klein bottle stuff. It wants to be absolute hot, 14160, like 30 zeros. 2.27 approximation plus or minus 0.00053, and the absolute cold Kelvin is negative 273 Kelvin. Now again, 2.72 is above bar, right?
Normalize the wave function. You can see it's just a squared. If we plug it 0.
Okay, the integral of its infinity cold, negative 273 Kelvin, out to 1416 30 zeros or 28 zeros, and we're trying to figure out 2.27 Kelvin approximation. that is what it is. Even a hillbilly like me that can't program, doesn't do too much chemistry, can tell you that is for sure true, as much as plasticity of your pickled rink against the wall running into it. And that is the absolute value of wave function squared. It is in a square aspect. This will square wave because of units. This eventually curve off one way or another is what gives it XYZ dimensions. It'll have a beginning and an end in that third dimensional space. And those units. So that's the difference, or at least here, the derivative of x, and that is 1. That is that from here, this becomes 0, and that is 1. That squares this wave function because now it's a different part of it. Now that you've done that, you're trying to find 0, I guess, for it, which is going to say the two parts is up here. The square has this. You're going, this wave function is hitting up here double oscillator. So the wave frequency, or the, I think it's frequency, no. Time to a frequency, frequency to a time function. That function has an absolute value of hertz, coulombs, 2.2, the approximation more likely, that's where it derives the 0.0005, because 2 gives me that number, which could be high or low. Then I know it's always on the high side here, creeping its way to cold, or 1s to 0s, or 0s to 1s, are a bit more superposition-y here.
0 into this function.
And now basically this is what it drew out. This actually gave us this number, infinity, and this number as it rotated or changed axis, to then give us 1 bar. That is approximately the half the distance of the universe at Big Bang. Any other M1, M2, Mn of it. And Big Bang can be a training program. Again, students in a classroom. This is where that 0, we can't use yesterday's numbers into this variable. They are their own unit that in a second order comes in and has its own high function or low function. But we don't really deal with negative time that way, kind of like 0 stuff, high and low. It's in a charge spot. It can be that, especially when we go from 0.
It should be more like divide that by the derivative.
Infinity to 0 to infinity. Then this is where that time to function comes in, where positive time is more what we'll deal with, as the unit from a point becomes how you perceive past, instead of saying that time travel is exactly liquid like that. You can look at your results as a calculus teacher. You can derive a higher certainty out of the probability from that, and this is that string theory line of code that helps you form that geometry. Some notes. Catch you on the next one.